Hi there, I'm Victor, and I'm a co-founder of Narwhal, and today I want to tell you how to use Angular effectively at large organizations. So I used to be at Google, worked on the Angular team, used to blog at savkin.com. Some time ago, Jeff Cross from the Angular team and I left Google to start Narwhal. And these days, I blog at blog.narwhal.io. So check out the blog, it has a lot of high-quality Angular content. Last year at ng-conf was just two of us, Jeff and I. And since then, we hired lots of folks, very smart folks from the Angular community. I think some people call us the Angular Avengers, which is, obviously very cool. If you see any of us, say hi. We're also hiring, mainly in Toronto, Canada. So if you happen to be in Toronto, join us, right? If you want to work on cool projects, work on open source, have flexible hours, and be paid really well, email me. If you're not in Toronto, still email me. We make exceptions sometimes. All right. I'm going to talk about using Angular effectively at large organizations. And there are a few components to it. So first, I want to start by explaining how large organizations differ from small organizations, right? And what challenges they face. Then I'm going to look at two main areas of focus that we identified by working with lots of clients, which is source code and dependency management and best practices and tools. And then finally, at the end, I will give you a practical checklist. You can print out, bring to work on Monday, and become awesome or whatever, right? I'm going to use an R1X in this presentation, which is our open source sort of set of extensions for the Angular CLI, optimized for large enterprise teams, right? So open source, it's MIT license, so I'm not selling it to you. If you use it, great. If you don't use it, well, less great, but fine still. So it's really up to you. And I'm going to use it because it provides good solutions for many of the problems I'm going to talk about. So you don't have to use it. You can implement the same kind of techniques yourself in your own custom setup, right? We just released 1.0, so it's stable. Most of our clients use it. And we are working on the next version that's built on top of Angular CLI 6. All right, let's dive into it. So on the surface, large and small organizations are similar. They care about the same kind of stuff, right? They care about consistency. If every team builds, their apps in a very unique, special way, right? The code is harder to reuse, it's harder to integrate. Having a consistent setup helps in many ways. It's code reuse and with team mobility, right? If a developer joins a particular team, she can go to another team and still be productive, right? They care about writing safe, robust, error-prone code, right? You want to make sure you don't have race conditions, your error handling is stopped correctly, things like that. They care about writing maintainable code, right? So you can make changes to your code with confidence, right? And sort of the theme is confidence. That's what it's all about, right? If developers can quickly verify that they can make changes to your code base, and if they feel confident, they will maintain your code base in a good way, right? It will be healthy, it will feel better, right? What's different about small organizations and large organizations is that large companies have a lot of people, like hundreds of or thousands of Angular developers building dozens or hundreds of Angular apps, right? And that changes everything, right? It's the same difference between your garage, right, and an Amazon warehouse. So in principle, they are the same, right? Storage spaces, but the processes you use in your garage won't work in an Amazon warehouse, right? So small companies can often get by very informal ad hoc processes, right? And those just do not work, right? At large companies, you need more structure. Before I jump into giving you concrete advice on how to set it up, right? I want to make a comment on why I think Angular is good for large companies, right? And maybe I'm biased because I was on the Angular team, so obviously I think it's good at lots of things, projects of all size and for companies of all size, right? But it especially shines, right, if you have a large organization. Here's why. The first reason is that the community is not fragmented, right? Everyone on the Angular community, most folks on the Angular community use the Angular CLI, use the router, right? Use NGRX or plan to use NGRX, right? And this uniformity leads to a much greater consistency. Right? So when a developer joins a team, she can become productive in days or let's say weeks, but still relatively quickly, right? She can move from a team to a team and remain productive, right? That's a huge thing, for many companies. And if you look at some other ecosystem, that's not the case, right? Every app there is unique, and as such, your experience doesn't transfer as well, right? Angular has predictable release cycle, right? Which is awesome for larger companies. Angular really loves TypeScript. And TypeScript, in my opinion, is by far the best thing that happened to the JavaScript ecosystem. One of the best things that happened to me personally, right? It's just so good, right? And it's not the only framework that works well with TypeScript. Like most of them do work really well. The difference here is that the whole ecosystem works well with TypeScript. Every single library, every single tool, right? And as such, your typings are now out of date. Your API is still ergonomic when typed. All the source code manipulation tools, use TypeScript, so you never have any mismatch. It just works really well. The experience is almost as good as you get, if you use Java, right? The tooling is excellent. So that's a huge deal, right? And finally, Angular has a very strong emphasis on automation, right? Things should happen automatically for you, which matters a lot more for large organizations, right? All right, so these are the two areas we sort of identified, the things you can tackle first in your organization, and if you do it, you'll be ahead of other folks. Basically, you'll be ahead of your competition. Let's look at the first one. As I mentioned, large organizations have a lot of source code, and lots of folks just changing the source code constantly, right? So figuring out how to store your source code, how to effectively make changes to your source code, how to set up dependencies between different units in your source code, right, between different projects, how to build and release them, are the questions you have to answer well and relatively early on, right? Once you start examining those questions, you will quickly see that not all projects or modules in your setup are alike. So there are different categories of projects. For example, you'll quickly see that there are applications that you actually build, something that you bundle, probably using Webpack, and ship to some user. You minify, you create an optimized bundle, right? There are app-specific libs. Those are sections of your apps you want to build independently and test independently. They usually have owners, right? You build a section of your app, you put some router in there, some business logic, right? And you then plug it into some app, right? There are reusable libs, like components, utilities, services, sometimes some NGRX stuff can be used as well. And there are third-party libraries and tools, right? To be effective, a developer should be able to do the following things, right? A developer should be able to create app-specific libs, sections of apps, quickly. A developer should be able to extract reusable libs and see what depends on them, right? A developer should be able to verify that a code change, a PR, is safe to merge. A PR to a reusable library is safe to merge, which is a lot harder, right? A developer should be able to refactor a bunch of those things together, determine who is responsible for a particular section, so ownership should be established, right? And then a developer should be able to view the dependency graph and impose constraints on that dependency graph, right? So going through all of them will take a long time, hours, right? So I'm going to just cherry pick a few examples to show you how good it can be if you just put a little bit of thought into it. You don't have to use our tools, right? It's thought that matters, right? And how unfortunately underwhelming it usually is, right? So the contrast will be, drastic, right? So hopefully it will inspire you to make some changes. Take, for example, extracting a reusable library. Common use case, we should do it all the time, right? To see the difference between how awesome it can be and how unfortunate it usually is, let's imagine we are working on some help desk-like app, right? Where folks can submit tickets, our agents can view tickets and do something with them. So let's imagine we have two applications implementing this project. The first one is called Task Desk, which is our main app, which our agents use. And the second one is called admin, some sort of admin stuff on the side, right? Those are two separate applications built for different folks in a different way. For example, the Task Desk app maybe works on mobile, the admin app, no one cares, works on in Chrome, right? And each of those is built using a bunch of app-specific libs, right? That's sort of the setup. Because it's in an X repo, we can run this command to get sort of the graph of all dependencies in this repo. We can look at all the libs, all the apps, and we can see how they depend on each other, right? Right now, we see that they don't share any code, right? Those two projects are separate, they're distinct, right? There is nothing that's shared, right? If we zoom in on this particular lib, component shell, we see it's used by one of the apps, the Task Desk app, our main app. Let's say we have an idea, and we can go over here to see this lib sort of a little bit closer. It has two components, footer and header, right? And the module just exports those two components. It's a very basic setup. Let's say we have an idea that we'd like to take one of these components, say footer, right? And use it in both the apps, right? Our product person talks to us like, we need to move it and use it everywhere. Do it quickly, right? So how do we do it? Like, what is the process of extracting that component out and using it in both the apps, right? In our case, because we're using the good set of tools, we can do it very easily, right? We can use the ng command and generate a lib of shared components, right? Again, we're not using anything special here. That's just US CLI. We just plug in custom schematics and then it allows us to do that, right? We generate a lib of shared components, relatively straightforward. Step 2, we're just moving the component over. You can just drag and drop the component. It's as simple as that, right? And then you update your module to export the component, right? Relatively straightforward. Finally, we import the new lib into our application, and then we import the module next to the original shell module, right? Which we move the components from. Right? Finally, we're running this command to make sure that none of the apps that in our repo are affected by this change, right? That they are not broken. It's a big deal, right? Because we want to make sure that our changes are safe, right? That when we are doing those refactorings, extracting things out, we don't break existing apps and libs, right? But we want to do it like efficiently. We don't want to retest everything every single time. That's at best not good, right? It will be very slow. It will break down, right? So you want to make sure that you only retest the thing that you have to retest and nothing else, right? And we can do it by using this command. So at this point, what we have is a reusable library. We can submit a PR to master, merge into master, and then eventually use it in our admin app in the same fashion, right? Because it's an X repo, again, we can run the same command we ran before to see that, hey, now we can see that the two apps actually have a shared piece, right? Note, we can actually measure the whole process from the idea in our head, I'd like to move this component out, to it's been merged into master. We can write down the steps and see how long it takes in the best case scenario. In this case, we have 4 simple steps, and it may take an hour, right, depending on how slow your CI is. Right? Now let's look at how it's typically done. Right? This is how it's typically done. So in most organizations, if I'm tasked with the same project, right, I need to share this component, I need to create and configure a new repo in my GHE instance, right, presumably. I need to stop testing, set up some sort of ng packager thingy, right, to publish it, to create the right artifact. I need to set up my CI to make sure that my lib is tested automatically. I need to set up deployment to a private NPM registry, to some artifactory, right? Only then, after I'm done with all of this, I can move the component over, test it, massage it a little bit, make it exactly right, add a README, push it to my artifactory, right? Then I go to the main app, I pull the package. Turns out it's not exactly right because as a human being, I make mistakes all the time. So I go through the same process a couple of times. Eventually, I arrive at something that works, right? If we look at this, this usually takes, in most organizations, at least a couple of weeks. Provisioning a repo, provisioning CI, setting it up takes a lot of time. Like, it's not a 1-hour operation. And the point here is that because it takes so long to do that, right? If it takes not even weeks, but if it takes multiple days to do that, it's very hard for me to go to my manager and say, hey, I need that component. I'll see you in a month. Only then I'll have it in this other app, right? Or I can just copy it over, and I'll be done in an hour, right? My manager will tell me, are you stupid, right? Copy it over, right? We have a deadline, right? So the idea is that because it takes so long to do it properly in a typical setup, right? Folks usually just duplicate code or put code in the wrong place from the very beginning, right? It doesn't belong there, but you know that that piece is shared. You just put everything there, right? Because you don't want to go through this process later on. It gets actually a lot worse. And a lot worse if you try to actually test that your reusable library doesn't, like a change to a reusable library is safe, right? It's painfully difficult to do it in most setups, right? And what it results in is that developers who cannot test that write brittle defensive code. So they're afraid to make changes, they don't have the confidence, right? They're always under stress, the hair gets gray, as you can see, as the result of my working in the industry, right? Lots of other things happen, right? That's not good. So it should be as simple as that. You should be able to do it by running a single command, essentially, right? That's what happens here. You should do it in the CI, obviously, right? Even more so, you should be able to run some command to see what exactly is affected by a particular change. If you touch a file or you submit a PR, you should know what can be affected, right? And in our case, we can do that. In your own setup, you should be able to do it as well, right? If you cannot do it in the long run, right, you're going to suffer. Let's see how it usually happens, right? If I have a reusable library in my setup and a bunch of apps using it, what usually happens is I'm making a change to a library, then someone on my team takes this change, pulls one of the apps that might be using the library, right? Then through magic of NPM link, which no one understands, or like very few people really understand, right? They try to hook it up, right? Let's imagine you manage to do that. And believe me, like very few people can do it well, right? You do that, and then you test the app manually, click around, like, yeah, it kind of works. No, there is no CI involved. We don't do it automatically. It's a manual process. It at best takes hours, usually takes much longer, and you usually do it with like one app. So you get some confidence it's not completely broken, right? But that's basically it. You don't test it with every single app because chances are you don't even know who depends on your stuff, right? So it's completely broken. It's shockingly bad, right? I'm surprised developers, can keep any sanity with this kind of stuff. So if you want to, so we looked at a few examples of how good it can be relatively easily, right? If you invest, enough effort, and how underwhelming it usually is, right? If you want to get better at those things, right? Check out those links. Explore the idea of workspaces or monorepos. Right? We have our own open source tool that does it, right? But you don't have to use it. You can do it on your own just fine. Check out the blog post. It talks about that. Explore Bazel. Lots of folks at this conference talk about Bazel. An excellent build tool from Google. Works really well. We have a Bazel-flavored version of NX. Works really well. Works somewhat well. So you should check it out if you're interested. Dan and Tor from our team, they wrote an excellent blog post introducing you to Bazel and how to use it with Angular. Check out the blog post. Explore Git submodules in Yarn workspaces. Really, really good tools. For some reason, no one uses them. Right? I'm yet to see a person who effectively uses Git submodules. Right? Just explore it. It's a very good thing to in many situations. Finally, enforce single version policy, meaning that in your org or like in your group of teams, use only one version of Angular, one version of every package. Right? Seems crazy and it seems like unproductive, but in the long run, you're going to win. You're going to have higher code reusability, integrate things is much easier. Your developers can move around without being stressed out all the time. Right? Now, let's switch gears and talk about the second area of focus, which is promoting best practices using tooling. Right? As with the previous section, the idea that the approach you use in your like a 10-person organization just doesn't work at large companies, right? Code reviews and word of mouth are great ways, or like chatting over lunch, right? Works really well with like 10 of you. It doesn't work if it's 1,000 of you, right? The process gets brittle. You need to put a lot of resources into educating folks in this way. Everything gets inconsistent. Basically, it's not working really well. To see if we can do better, let's go back to this picture, and let's imagine, right, in this case, that we have been working on this repo for a while. We worked on a few apps, those 3 apps, and we sort of discovered, just based on our experience, that the green boxes, the libraries, it's better if they play one of the following 4 roles, right? Let's say we discovered that if we partition our repository in these 4 categories, we have utilities, DOM components, meaning the UI, engineering stuff, the data access, and features, which is the actual thing that glues everything together. If we partition our repo in those 4 categories of libs, somehow it's more maintainable. Let's say that's what we've learned, right, from our experience. So we would like to, promote this idea, right, so folks at our company create those kind of libraries. In addition, we'd like to say that, they shouldn't depend on each other freely. Like, it does make sense for DOM UI components to depend on the GRX stuff. Right? That just shouldn't be the case. Similarly, if you have GRX stuff, it shouldn't depend on components. Right? It should be abstracted away. So let's say we want to impose these constraints on our repo as well. How can we do it? Right? Typically, it's done like this. Someone, an architect, right, writes a wiki page describing the setup. Right? That page gets out of sync like in a day. 3/4 of the company didn't hear about the page and never read it, right? It's basically, it's not a waste of effort. It can be still productive, right? But we can do a lot better than that, right? Sometimes folks try to use code reviews to do that, which works to a degree. Right? Code reviews obviously help a little bit to promote best practices, but certain things like, say, checking dependencies that they're like allowed or whatnot, right, can be hard to spot. And in general, it's a good idea to sort of make things sort of build quality in, right? So you cannot make a mistake, rather than relying on after-the-fact inspections, which code reviews are, right? Let's see if we can do better than that, because that's a low bar, right? If we look at this again, we can sort of see that we need to do two things to be successful here, right? First, we need to enable folks to generate libraries based on some archetypes, right? If I'm generating a data access library, I should be able to express it, right, as a developer. Second, we need to create a link check to make sure that certain dependencies between our libraries are not allowed. Simple as that. Let's see how we can do it. Again, in this case, we're working in the next repo, so certain things are a little bit simpler, but the same kind of stuff is possible if you have your own homegrown setup, right? It just will take a little bit longer. So here, we're using this command. Again, we're using the standard CLI tooling to create a workspace schematic, a special folder in our workspace. We call it data access lib, all right? Then we provision schema.json with that schematic. Essentially, we're defining inputs, what this schematic needs to execute, right? In this case, we have only one input, which is the name of the library we're trying to create. Next, we're writing the implementation, and here the implementation is relatively straightforward. We're just invoking two existing schematics. We're creating a library, and we're creating ng stuff and just adding to the library. And in addition to that, we are running some checks to make sure that naming is consistent, because we value that in our repo. And that's everything we need to do to enable code generation piece. It's like 10 lines of code. Then we add some linting constraints, and I won't go too much into this, so don't worry about this as much. Just look at how little code is required, right? There are 2 lines of code you need to write to make it happen. With this in place, any developer, is able to run this command, and using the standard CLI setup with a little bit of help that NX provides, create a data access library. Right? And if you look at the implementation again, we create a lib, and we create indirect stuff in this lib. And that's what we see over here. There is a lib with indirect stuff in that lib, right? Everything is configured properly, everything is named properly, invariants are enforced, tagging is set up properly. Everything is done for you, right? Linting is set up properly. So if you import something which you shouldn't be able to import, you're going to get an error, and your CI will fail, right? And again, in this case, because we sort of optimize for this use case in our open source tooling, right, it takes 10 minutes to do that. If you do it on your own, okay, it will take a day or whatever, right? But it's still possible. So you should do it regardless if you use our stuff or not. The next one, again, I want to stress it, that even in a small company, you probably will have at least a few dozen projects that depend on each other in all sorts of ways, right? Being able to visualize that workspace, see what depends on what in what way. What's loaded lazily, what is not loaded lazily, right? It's variable, it's immensely variable. And if you compare it to how it's typically done, and again, someone opens OmniGraffle, draws some diagram, which is wrong from day one. It's not even like it was never right? Publish it to a wiki page, it's ignored, and everyone is sad, right? Again, with a little bit of effort, you can get up-to-date information all the time, comparing to something that basically provides very little value. Some recommendations: create custom schematics and custom link checks. It takes quite some time to become familiar with schematics and TS-lint, but it's totally worth it. The payoff is huge, right? If you are not doing it, you should be doing it like soon. The value is just immense. Next, automate everything that can be automated. Just absolutely everything. Right? You think I don't need to automate it? It's a mistake, right? You want to automate it. For example, in our case, we force you to format stuff as pre-tier, and then force you to run pre-key checks in your CI, so you make sure stuff is formatted properly, right? Things like that you just have to do. It's very easy to do. It takes a data setup, and then you're living in a much happier place. So there is a checklist, and I was thinking about going through checklist very slowly, sort of point by point, but then it's very long, so I'm like, screw it. So I'm going to point you to a blog post that talks about the same stuff in a much better way, with a lot more detail, and at the end has a checklist. So check it out. If you want to print it, I actually bring it to work. If you hit this URL, you're going to get a PDF version you can print. You can bring it to work on Monday, and hopefully, improve performance of the organization. Oh, sorry, you can take a picture. I'm going to share slides on Twitter. So, all right, cool. So follow me on Twitter. Talk to me at the Narwhal booth, which is right over there. I'm happy to talk to you more about enabling those kind of things at your company. We're also hiring, so shoot me an email. Work for us. There you go. Thank you.